For IP address version 6 multicast, there are two major types for multicast. There is the assigned multicast and there is the solicited node multicast. Solicited node multicast is frequently used for sending control information between the routers, as we will see in a minute. The assigned multicast can be all node multicast, in which case it corresponds to broadcast. And the all node multicast will start with FF02 and then colon 1. So this actually represents the all nodes in that case. There is also all router, which is used between the routers in the wide area network to send, for example, routing information between all the routers, and in that case we send to a particular IP address, which is FF02 colon 2, and this is for all routers. And anything that starts with FF02 is multicast, which again, any of these nodes can participate in this multicast group, in which case we can send only to 2 nodes or 3 nodes and so on, similar to IP address version 4. There is also the other type of multicast address, which is what we call solicited node multicast. In that case, each node will have to generate this multicast address locally, and then it participates automatically in the multicast group with this address. And this address can be, or this multicast group is used, send some control information between the nodes. So each node will calculate this solicited node multicast address using the process that we will talk about now. So, so the solicited node multicast is actually divided into 2 parts. The first part is fixed, which is FF02 colon 0 colon 0 colon 0 colon FF0 and then colon, which means that the first 104 bits are in fact the same, and it's fixed, and you have the rest, or the last 24 bits of the address, which will be assigned from the last 24 bits in the global unicast address. So again, it's solicited node multicast is 2 parts. Part from the multicast address range, and the last 24 bits are straight or direct copy from the global unicast address. So if the global unicast address is 2001 colon 0DB8 and so on, so instead of these 104 bits, we assign the multicast address 104 bits from multicast range, and then the last 24 bits will be copied straight from the global unicast address. So that's what we call the solicited multicast address. So the third and last section in chapter 8 is verifying connectivity. And for verifying connectivity, we use ICMP protocol. So the ICMP protocol is used to send echo requests and echo replies to particular IP address to verify the connectivity, whether to verify the connectivity within a host, or to verify the connectivity on a network, or to verify a connectivity to the remote network. ICMP message can be sent using either version 4 or version 6, and the response to that could be either host confirmation. If the host exists, it sends a reply back, and in that case we confirm the connectivity, or we may get an error message like destination or service unreachable, in which case we recognize that there is a problem with the final destination, or time exceeded if the request actually is sent and it spends a time on the network which is more than what's configured. In that case, we get a time exceeded, or route redirection, which means that the router actually will fail and will send back an ICMP reply to indicate that it does not have a route to this particular host. So this is the explanation for each of these error messages. In addition to the normal host connectivity, the ICMP version 6 adds another other set of messages which are used for router solicitation. So there is the router solicitation message that the host can use to send a request to the router to obtain, as we have said before, to obtain the prefix and the prefix length and the default gateway. And in that case, the router will respond back with this information, and then the host will use the EOI method, as we have explained before, to calculate the interface ID using the MAC address. Another feature in ICMP version 6 is what we call neighbor discovery protocol. And this will be used similar to ARP. So ICMP can actually be used for address resolution if we want to achieve or to obtain the MAC address, the Ethernet address that corresponds to a particular IP address, similar to ARP, or it can be used for duplicate address detection. So if a host assigns arbitrarily an IP address and an interface ID using the methods that we have explained before, it's always useful that the host can send the DAD request using ICMP protocol to the router to make sure that the address assigned is actually a unique in that case, and there is no duplicate assignment of that address. So if the address gets assigned arbitrarily, it's always useful to try that feature of ICMP to make sure that the address assigned is unique. There are three types, as we said, for checking or verifying the connectivity. There is ping to 127.0.0.1 or loopback. In the case of IP address version 6, this is ping to address column 1, which is the loopback address. And in both cases, when we ping this loopback address, we make sure that the TCP/IP configuration is installed and working properly, because the host will actually ping itself, will send the packet to itself, and it will not send the packet to the network, in which case we only verify the stack of TCP/IP, whether it's working fine or not. The other part is to verify the connectivity to the local network, and in that case, the host may actually ping the local gateway or the default gateway in order to make sure that it can communicate through the network, in which case the ping will send an ICMP request using echo request to the router, and the default gateway will send back an echo reply to indicate that the connectivity to the local network is working properly. And the third type is to verify the connectivity to a remote network, and in that case we have a router here with two interfaces connected to two networks. These interfaces have these IPs or connected to these IPs in the routing table, and in that case, if host 10.0.0.1 wants to verify the connectivity to another host 10.0.1.1, in that case it will send an echo reply, and the router in that case will have to forward this echo request through from the table here, and then it sends to the right IP address, and if that host receives that echo request, it will send an echo reply, and this will be the way for this host to verify the connectivity. The ping is used to verify the connectivity, but it does not give us any information about how we can get to this host. So for example, if this host here wants to not only know the connectivity or verify the connectivity to this remote host, but it also wants to get some information about the time that it takes to send back and forth to this host, and what is the probable route that the packet will take if it sends to this host. In that case, the ping request will not help. Instead, there is another command which is called traceroute. The traceroute gives us more information in addition to the connectivity. It gives us the round trip time, the time that the packet takes to be sent all the way to this host and coming back, and the probable route that it takes to reach to this. So if we say trace route to this IP address, the router will first send back a response, the first response to indicate that that the packet arrived to this router, and then this router will use the routing information to send to a particular router based on the routing table, and then this router will have to send back another request to indicate that I'm the next hop and I'm the next hop and so on. And this way we can learn and we can get information about the probable route that the packet takes to reach all the way to the host. So we keep doing this process repeatedly. Each route will have to send back a response until we reach to the final host, and then the host will send back an echo reply that the final destination has been reached. So here we get information about the round trip time, and we get information about the probable route. This chapter we talked about IP address version 4 in section 1, IP address version 6 in section 2, and how to verify the connectivity using ICMP protocol in section 3. In section 1, we talked about the address structure. We talked about how to divide the IP address version 4 into a network part and a host part, and how to use the subnet mask to do that. In IP address version 6, we also talked about how to summarize the representation or the notation of IP address version 6 using the leading omitting or omitting the leading zeros. Then we use double column to abbreviate the notation of IP address version 6, and what are the different types of IP address version 6, whether it's global unicast, link, or local link, or unspecified, and so on. Connectivity verification, we talked about how to verify the connectivity to whether it's loopback for verifying the configuration of TCP IP, or to verify the connectivity to the local network, or to verify the connectivity to the remote network using the ping command, or to get more information about the probable route and the round trip time using the trace route. So again, that concludes chapter 8.